scientists, they're saying, so they're going to sit down there rather than coming up here and being blinded by the light. Also, another opportunity for you to be interactive. This is the interactive part of this afternoon. So, 6 faculty members who have a wealth of knowledge are going to share with you and get it done in 60 minutes. Your response is, wow. Wow. That was pretty mediocre. Wow. Oh, yeah. Well, we know that's not really going to happen, and that these lovely people in the back there are going to feed you all this wonderful food, are going to have cold food, if I didn't bring the famous egg timer. So we're going to really make sure that in 8 to 10 minutes we get our job done and give you some factoids. What do the numbers 3, 7, and 10 have in common? They wondered. I want you to get engaged because you need to ask us questions at the end of this. 3 things that are of interest to you during these presentations. 3. And if you use those 3 things 7 times in 10 days, they will be yours forever. 3, 7, and 10. I'm serious. And people in the back said that we're going to have a big party later on. You don't get any food unless you participate and ask questions. Okay, so there's the deal. Now, I'm not supposed to talk anymore. I'm going to introduce our first speaker. We're going to keep introductions real short because these are CSU experts, or they're on the CSU campus, and you can look up more information. But our first speaker, we're going to tell you 6, we're going to set the table, as it were. And our first short story is by Professor Fatberg. There you go, I love it. Fatberg, and Pat is in the Department of Soil and Crop Science. He got his doctorate. Come on up, Pat, because you'll be ready to rock and roll here. He got his doctorate degree from the University of Missouri, I believe. And he is a plant geneticist, and he's going to set the table with the first course. He's going to talk to us about corn. I'm going to put our own egg timer friend up here, punch it on. Take it away, Pat.
Well, good morning, or good afternoon, everyone. It's my honor to be part of this event and to kick things off with our crop specializations. Corn, to me, is one of the most interesting crops we have out there. I worked on it for many years, both in the US and in Mexico. And I'm going to tell you something about the history, the diversity, and then a research project that I was part of a few years ago. This is a picture from a holiday card I received recently from Native Seed Search. Isn't that a great image? Hints at the diversity within the corn germplasm. Of course, diversity in the things we eat as well. And I'm sure we all have many favorite foods from corn. These are a few of mine. Tender, fresh, sweet corn, popcorn, cornbread, and aren't tamales great? Not only is it the main ingredient, but it's part of the cooking apparatus too. Of course, the way we mostly eat corn is through animal products, and in recent decades through high fructose corn syrup that seems to show up in many things. These are products we need to eat in moderation. Well, as Stephen mentioned, corn is a New World crop, and it really is a gift of Native Americans to the rest of the world, because corn is grown just about everywhere now. And when the Europeans arrived here, corn was already distributed from Canada all the way down into South America. So a lot of selection or adaptation to different altitudes and latitudes and pest problems had already taken place by the time the Europeans arrived. And we know now, through archaeological evidence as well as new DNA data, that corn originated in southern Mexico about 9,000 years ago. And we even know with some assurance which river valley. It's the central Balsas River Valley in southwestern Mexico. And the data is convincing now that corn originated from a wild plant called teosinte, which is a very bushy plant with many branches and many ears are seed-bearing structures. So look at the difference there from this wild plant with many small seed-bearing structures to the plant that we know, a single main stem, one or two ears. And even more amazing, perhaps, is the seed structure itself, because originally Teosinte just had 2 rows of seeds, and now a modern ear would have something like 16 or 18 rows of kernels. And the seeds were encased in this very hard covering, like a nut would be, with the seed inside. So some pretty dramatic transformations took place to get from this plant and this seed structure to the corn we know now. Amazingly enough, scientists have determined that it's probably mutations in 5 genes that are responsible for all those conversions. So since that original domestication, corn has just proliferated in its diversity. Corn is considered 2 to 5 times more variable than other grass family crops like wheat or rice, 14 times more variable than humans in terms of DNA variation per length of chromosome. Variability is due to a high mutation rate inherent to the corn species, as well as the large population sizes in corn in Teosinte fields. One of the reasons for the high mutation rate are transposons. And maybe you've heard of the term jumping genes. This was the phenomenon for which Barbara McClintock won the Nobel Prize. And it's the ability of a section of DNA to excise from the genome, from the chromosome, and reinsert itself elsewhere, in the process creating mutations, some of which are useful. Now, this has been taken advantage of recently as a genetic research tool, not just in maize, but in other species as well. So an example of how the dedicated research of a woman, again, has led to a tremendous explosion in corn research. A lot of different grain types in corn that you might have heard of. Dent corn is the principal one that we grow here. These types are distinguished by the types of endosperm, our starchy material, in the seed. So a dent corn is mostly starchy. Flint corn would have more flinty or glassy type endosperm. Flour corn, of course, almost all starchy. Popcorn, a very specialized type of flint corn. Now, sweet corn, which we all love, is very interesting. That is the result of mutations in the biochemical pathway leading from the conversion of sugar into starch. Now, starch is a much more efficient way for a seed to store its carbohydrate reserves, but it's not that great for eating fresh off the cob. Sugar is what we want, so if you block that conversion, you can get the buildup of sugar. There's now about 8 different genes that are used for sweet corn commercially, either singly or in combination. Hybrids. Corn is the premier example of the use of hybrid vigor. The ability of when particular inbred lines of corn are crossed together, the plants arising from the seed are much more vigorous, productive, more robust than either parent. And this phenomenon is the basis of our corn seed industry. Almost all the corn grown in developed countries is now hybrids, and increasingly in developing countries as well. Hey, blue corn. This is showing up in more and more food products and is part of our menu this afternoon. Before coming to CSU, I worked for several years on the genetics of the biochemical pathway that leads to anthocyanins, which are down here at the bottom. And I could tell you lots of interesting stories about this, but it's pretty complicated, so I'm not going to do that. But I'm going to tell you how we applied this pathway to a problem here in Colorado.